Jai Janendra, Namaste. My name is Sayyam Jain. Welcome to my channel. Today we are going to solve the 38th question of the problem solving series, which is based on greedy algorithm. This is the second question of greedy algorithm that I am teaching in this playlist of placement series. So we need to find the minimum platforms. The difficulty level for this question is medium, and this question has been asked in Google, Atlassian, Microsoft, Adobe. It's a very popular question. So minimum platforms required in railway. Generally, it's given mentioned in the as part of a railway, but it could be any other platforms also. So assuming that we have a railway stations and a lot of trains are coming in the railway stations, we need to find the minimum number of platforms that is required to accommodate all the trains. That means if one train is coming, the other train doesn't have to wait. We have extra platform. In the previous question of the greedy algorithm, we were finding the maximum number of meetings that can happen in single room. There were like 8 to 10 meetings that were given, but we had to take the maximum number of meetings, could be 3 or 4, that can happen only one room. But in this case, we have to accommodate all the intervals, start time and end times, and we have to return the number of rooms or number of platforms that we need to have all those meetings or uh, train accommodate. Okay, so let's see this example first. So there is a train that comes at 9 a.m. and arrives at 9 a.m. and departs at 10 a.m. Then the next train comes at 11 hours and departs at 12 hours. Then the next train comes at 12:30 hours and departs at 12:40 hours. Say if we had one platform, the first train comes at 9, goes at 10. Then the next train comes at 11. Can it come in the same platform? Yes, it can. And goes at 12. And the next train comes at 12:30 and goes at 12:40. So with one platform, we can accommodate all the trains. So what would be our answer? Only one. We need only one platform to accommodate all the trains. Okay. And is the start time of the arrival time of the train and the departure time of the train. And these are the number of trains. We find minimum number of platforms that we need to accommodate all the trains. If we see the second example, a train comes at 9 and goes at 9:10. Okay. And the other train comes at 9:40, goes at 12. So we have assumed we have one platform. The first train comes at 9 and goes at 9:10. The second train comes at 9:40 and goes at 12. Both the train can be accommodated in the same platform. Now the third train comes at 9:50. Now already in the first platform we have 9:40 train that is there and that is going to arrive at 12. Can another train come at 9:50 in this platform? No, it can't, because it's already occupied. So what do we have to do? We need another platform. So say if we have another platform and this train comes at 9:50 and goes at 11:30. Now we have two platforms. Now another train comes at 11. Okay, and goes at 11:30. So this 9:50 train goes at 11:20, and now we have another train that comes at 11 and goes at 11:30. Okay, now in the first platform, now 9 and 9:10, this is done in one platform. The second platform, in the second train, so we have say three platforms like this. Okay, this 9:40 and 9:50 is occupied here. Now the next train comes at 9:50. So we have another platform for this 9:50, and this goes at 11:20. Now we have two platforms now. Now we have another train that comes at 11. Can this 11 a.m. train come at this platform? The 9:40 train goes at actually not 9:50. 9:40 train goes at 12. Sorry, my bad. 9:40 train goes at 12. And 9:50 train goes at 11:20. Now we have another train that comes at 11. Can it come in these two platforms? No, it can't. So we need another platform now. This 11, we need another platform, and this should go at 11:30. So already for these 3 trains we have to have 3 platforms. Now with these 3 platforms, can all the other train we can take care of them? So the next train comes at 3. So already these 3 trains are vacant, right? You see the end time. So this train can come at any of these platform. The 6 a.m. and it would depart at 7. And this 6 a.m. can come at any platform because all these 3 has got vacant. So the maximum number of platforms, minimum number of platforms that we need is 3 in this case. So how do we solve this? So what do we need to do now? Or what is the approach? I think the question is clear. We need to find the minimum number of platforms that can accommodate all the trains. All the start, it could be the minimum number of meeting rooms. That if the question could be that we have a lot of meetings, find the minimum number of meeting rooms that is required. So it could be turned to that way also. Okay. So how do we find this? This is different, little bit different from the first question. But in both the questions, in the previous question, but in both the 37th and the 38th question, we will use greedy algorithm. So in the previous question, I showed how the end time is required, like the meeting which ends early, we are prioritizing that and we are taking it. So that was the greedy approach. Now in this question, what do we do? How do we solve this? The brute force approach for this question would be the way we have just done it. Okay, so we can take train timing and we can see how much overlapping it can take. Say for example this one, if we take this train timing, for other we can check with all the other arrivals of the train, that is it overlapping with other train. Is the end time of this one overlapping with other train? If it is overlapping, we can increase the counter. So for all the train we can check, like for example this one we checked and we got okay. We need three platforms, right? So again double loop, okay, for checking for everyone and finding the max of the maximum number, means the number of platforms that we require for one train. Increase the counter, keep on increasing the counter and then get the max, okay? And then again start from this and do it for all the trains. For how much, for how many trains does this timing is overlapping, and we find for everything. Okay, that way, because once a train comes and goes, this platform becomes vacant. See, you need to observe this, that if 9:40 to 12, this train has come and now, so these 3 trains are occupied now, and we see that another train comes at 3. So this can come at any of these, right? Because these trains are gone now. So though 3 to 7 and 6 to 8 are overlapping, but already we have 3 platforms that we needed at this time. So this can be adjusted. So with the 2 loops, we can find for how many overlapping is happening for one timing. The maximum number of overlapping when we traverse for all the timings we will get, and that would be our answer. So that in that way, the time complexity, the brute force time complexity would be order of n square, brute force, right? But what would be the optimal solution? Optimal solution, we will be doing it, and that would be order of n log n. We will sort the timings and then we will see at what time how many platform is required, and we will use the greedy approach. So what do? We will sort the timings, okay? Sort every time. Start time we will sort, end time we will sort, okay? Say for this one, this is already sorted. Say the start time is sorted, the end time is sorted. So now what do? If we check for this one, say this train is already there, we have one platform. We check for this one, okay? Do we need this end time is actually smaller than the start time, right? So actually this train can come over here, right? So we don't need to increase the number of platform. So the number of platform would be same. But if this was more, if this was less than the end time, then we had to increase the number of platform. We would increase the number of platform. Okay. So in this case, the number of platforms will be same. And so we will have let me code this, and probably then you will understand how we are using the greedy approach to solve this problem in order of n log n. So what I'll do, I'll sort the start array. Okay. ST plus N, and short END plus N. Okay. Now we will have I equal to 0, J equal to 1, and platform, because there has to be at least one platform, so platform equal to 1. Now while I less than and the number of platform. Okay, what do we do? If start time st of I is less than if start time, if start of j, okay, j is 1, right? Start of j is less than end of I. Okay. So what will happen here? If the start of time of this one, okay, is less than, if it is greater than, say, start of j is greater than end time, then we don't have any issue. Okay, so we will decrease the number of platform. But if it is greater, okay, start time of j is actually less than end time, right? Then what do we need? We need to increase the number of platform. Platform would be increased. Okay, and then what do we do? Platform would be increased, and our end time will also increase. Okay, else we will don't need extra platform, so we will decrease the platform time. And what do we do? Since we have decreased the platform time, that has already been taken, we will move to the new arrival time, j plus plus, right? And this will be closed, and we will return. Okay, here we will have platform we are increasing and platform we are decreasing, and we have answer, which will take max of answer and platform at every point. Okay, and we will return answer, and our answer value would be in answer as 1 every time. Okay, so now I'll explain this code for probably we'll take any example, say this example only. Okay, what we have done over here, we have applied a greedy algorithm. We have answer equal to 1 because the minimum number of platform is, like, at least we need one platform. We have shorted the start time, we have shorted the end time. Though this will make changes to the arrival and departure time. Okay, if for example here 9:40 actually departs at 12, but if we short it, then it shows 11:20. But that will not cause the issue, because you need to understand it that one train we are focused with the end time. Okay, if a train is departuring at one time, then only the next train can come. Okay, so once we short it here, start of j, let's discuss it for this example, then it will be clear. So here in the beginning we are starting with 9. Okay, so j is 1, I is 0. Okay, so start time of this one, okay, 9:40, the second start time. Okay, if it is assuming that this has been arrived, 9 and 9:10 is arrived, okay, then this end time is at 9:10 and the start time is 9:40. This is the first, this is the second. Okay, now since this is less, so we don't need any extra platform. Start time is actually greater than the end time, then we don't need the platform, because this is the start time for the next train and this is the end time for the train that is already there. Okay, so we can reduce the number of platform. Okay, so platform becomes 0 and we increase. Okay, now the new train has come, we have increased this j plus plus. J plus plus is dealing with the end time, I is dealing with the start time. So once we increase, then doesn't mean that the number of platforms becomes 0, because maximum at least we need one platform, so we have answer to take care of that. Now the end times become this end I. This end I actually becomes the end for this 940. Not for 940, the second arrival time. Okay, 1120. Now this 1120, is it less than 950? Because the next is 950, right? 1120 is not, this 950 is not greater than 1120. That means we need to increase the number of platform. So the number of platform will become again 1. Okay. So now when the number of platform again becomes 1, again now we do it for 11. Is 11 greater than 1120? No. Then the number of platform will again increase to 2. Okay. And then once this is done, then for this one it will happen. In this way, we will get our answer as 3, because at one point it will come that this end point 1130 will actually be greater than 940, 950 and 11. That point of time our platform will increase from 1, 2 and 3. This is the greedy approach we are following. We are shorting it and we are comparing the end time with the start time. And we are increasing the number of platform. Okay. So I hope the explanation is clear. Try to solve it yourself. The link to the question is given in the description. And then come to my code walkthrough section to see what are the examples, how it runs, and check your code. Okay.
Here is the code walkthrough of the 38th question, minimum platform. So this is the same examples that we have discussed. Okay, so let's look at the code. We have sorted the arrival time and the departure time, and we have this count, and we are increasing the count if the arrival is less than departure, and we are decreasing the count if it's not, and we are taking the max count value every time. Okay, so here I forgot to add that okay, j also should be less than n when we are doing it, when we are increasing it. So this would also be the condition, and in this way, in order of n log n time complexity, you'd be able to get the minimum number of platforms that we require to so that all the train with this timing can be adjusted. So let's submit this directly. Okay, so this has been accepted. Let me know in the comment section how was the explanation, and see you also in the next video where I'll be explaining 39th question of the problem solving series. Thank you. Jai Jinendra.